Hello and welcome to the Foresight Longevity Tech Tree. My name is Aaron King and I work for Foresight Institute right now. So we're just going to go over the features of this tech tree and I guess the future directions that it could be taken in. To start with, just really basic navigation stuff. Grab the black background and drag to move around, zoom in and out with the mouse wheel. I put in a QR code here, which is a good idea mentioned by others to make it easier to find the domain name, but it's up here, foresight.org/ext/foresight tech tree. So it's been simplified a bit. And the idea is that we've got three general concepts: challenges, technology, and off-target applications. So we can take a look at something like I don't know, preserved organs, or maybe what's a good example? Advanced citation end products. We can see there's a discovery, there's diagnostic tools, then there's how do we modify these things, and then what kind of diseases can be addressed by getting breakthroughs in understanding advanced citation end products. We also have the labs and companies for every subdomain of longevity technology. And then we have connections between other domains with the dotted lines, as well as connections towards the end goals. And so on the right here are the sort of general end goals that these technologies are driving towards. So there's body replacement, which is a strategy of simply replacing everything that's going wrong. Body enhancement, which is to enhance the body beyond normal in an effort to live longer. Reducing the rate of damage accumulation and increasing the rate of repair, as well as simply slowing time through either hibernation mechanisms or cryonics. So this is everything. Or should be everything, and if it's not, let me know. But it's got right now the usefulness is kind of an assembly of keywords and connections, and like how do these concepts connect to each other, and what concepts might feed into other concepts. For instance, here we have the microbiome, and one of the outputs of the microbiome is to be able to remodel the microbiome into an ideal state. And that affects dietary control, because with dietary control, there's two general, I guess, domains of how do you change your diet. And one is to alter the timing, and the other one is to alter what it is that you eat. But if you change what you eat and your microbiome is different from somebody else's microbiome, then your results are going to be different. So you can't, it's hard to get advice from people if you don't know enough about your microbiome. And then, well, dietary control, that output is to upregulate autophagy, generally speaking. You modulate insulin, which modulates mTOR, which modulates FOXO. And that goes to autophagy. And so why is autophagy important? Well, because it helps you with increased turnover of damaged cells and lipofuscin degradation and other things like that. And that leads to increasing the rate of repair. So we can actually cluster these technologies into sort of together into certain subdomains of technologies are related more to others than they are to the rest of the field. Hopefully that makes sense. So we're at various stages of completion for all these tech trees, but I think that going forward here, the thing to do is to try to get either workshops or some kind of more rigorous structure for how do we build these things out. And I had a couple ideas. One is you make workshops for every single domain, and you ask all the labs and companies to come into a room and discuss, like, what is the field, what's happening in the field, where is it going, what's the current state of affairs. I've had several conversations recently, and I've realized and I guess I kind of suspected this for a while, that I've always seen this as a cooperative effort, but actually it could be adversarial, and it probably is adversarial in the sense that many people simply don't want people to know what they're doing. And I'll give you a very good example. With autophagy, where is it? So with autophagy, the entire field is bottlenecked by the fact that we cannot measure autophagy in vivo in near real time. And this is a big bottleneck for dietary control as well, in that there's no fasting autophagy data in humans. There's actually no published literature that shows that intermittent fasting or metformin or rapamycin has actually induced autophagy in people, because there's no way to measure autophagy in the body in vivo, and so it becomes very difficult to validate any of these therapies, right? And you could imagine that many of the people in the field might not want to not want this information to just be public and out there for everybody to know. I mean, I want it to be known because I want people to be more informed and to know what's going on, but it might be difficult. So to get them on board. So that was I don't know. We'll see what comes of that. I think that it's very important to understand what the bottlenecks are for all these technologies and why they're not currently producing value the way that they should be, and then to focus efforts on trying to fix those things. But some of them are very difficult. Measuring autophagy in vivo is just really hard. Some of these things, some of the bottlenecks are actually not that difficult. There's some stuff you can do with heat shock and cold shock and other certain things. There's a lot of value in germline biology that's not really being explored well. So there's things here that I've found to be of high value to myself as I've wanted to know what's going on in the field. We'll just have to see, I guess, if other people feel the same way. The other way to do this is maybe to get Foresight Fellows to pick a domain that they're most interested in, do a deep dive, literature review, build out any particular domain very deeply, and then have them form a network. And then as they move into the field, they leave behind this body of information that then just sort of builds the tree out. I think that's a pretty good idea. Obviously not as public facing as the original concept, but I think it still works very well. I'm not sure if having the public edit this thing is very useful. I think that there's probably, so I don't know if you know this, there's a 99-1 rule of any internet community, and probably of any community in general, which is that 1% of the people will do 90% of the work, 10% of the people will do the rest of the work, and then 90% of the people, or sorry, 1% of the people will do 90% of the work, 9% of the people will do the rest of the work, and then 90% of people will do nothing at all. So that's where the 99-1 rule comes from. And that seems to hold pretty true. It's especially prevalent on Wikipedia. So I just feel like trying to get the average layperson to contribute deep information to this is probably not the right place to be pushing a lot of our effort. And so I think it's fun. Like right now, the tools is actually what built out to an extent where we can go ahead and have fellows edit it very well. Sorry, I'm getting into the weeds a little bit here, but I think that just to wrap this up, I guess it's looking really good, and I'm happy with how it's turning out and what the content of the tree is so far. I'm not sure that it's going to provide a lot of value to everyone, but I think anyone who's really interested in longevity, um, might will probably find this useful. I mean, I know I have. It's pretty good stuff in here. And I actually am coming back to it and using it when I forget, like, oh, what was that company that was associated with reactive oxygen species or something, preserved organs. Um, I've used it a lot, and hopefully you can get some feedback from people. I think that it's a pretty good project, and I'm hoping that you guys find it useful. I guess that's all for today. Thanks for watching, and see you in the future.